So today we're going to go a little bit back to geometry. We're going to combine what we learned before, what you learned in Helen's class, with what we're learning right now. So we're going to talk about circles. I'm getting really good at drawing circles. Okay, and we are still learning about radians, right? So here, let's make an angle. And let's say this angle has a radian measure of 0.6 radians, okay? And what we're interested is how long is the arc, this arc over here. How long is the arc of the circle? Well, to find this out, we first need to know what is the radius of the circle. So let's say the radius of the circle is 3 centimeters. 3 centimeters. So again, we are looking for the length of the arc, which lies across from the angle, which has a measure of 0.6 radians in a circle with a radius of 3 centimeters. Okay, so the question we're going to answer is how long is the arc across an angle of 0.6 radians in a circle with a radius of 3 centimeters. After we learn how to do this, you're going to practice on your own, and then you're going to do a couple of problems which are use these ideas in the real world. Okay? So to find our answer, first, as usual, something we've been using a lot, we're going to write a proportion. The reason we can write a proportion is because the angle measure, the reason we can write a proportion is because the angle measure is proportional to the length of the arc. Across from it, the length of the arc. Okay? So, what does that mean? What am I actually saying? I am saying that if you have a big angle like this, you have a big arc. If you have a small angle like over here, you have a small arc. This is kind of just logical, right? So we also know, to write a proportion, we know that the the size of a circle, right, is 300. The size of the angle, central angle in a circle, is either 360 degrees, or we can also say that it is equal to 2 pi, right? So a circle has 360 degrees inside, or it has 2 pi radians inside. And this is going to be proportional to the length of the circumference of the circle, And we know the circumference of the circle is equal to 2 pi times r, times the radius. So we're going to use this information to write the proportion. So 360 degrees, or 2 pi radians, correspond to 2 pi r centimeters, meters, whatever measuring unit we're using. So here's the proportion we're going to write. 2 pi is on the bottom, and it's equal to the length of the arc, the entire arc is 2 pi r. The entire circle has an angle measure of 2 pi. Well, in this case, our angle is 0.6. So on this side, we're writing about the angle. And on this side, we're writing about the arc. And the arc, we don't know. It's an x. So we're just going to put x. Now, to solve this equation, what I have to do is get rid of some things, everything that's next to x. So I'm going to multiply both sides by 2 pi. Great, I can cancel them out, 2 pi out. And what I'm left with right now is 0.6 equals x over r. Well, I know what r is. R is 3 centimeters, so I'm going to write 3. Now I'm going to get rid of the 3, so to get cancel the 3, I have to multiply by 3. 3's cancel out, and what I'm left with is x is equal to 3 times 6 is 18. There's one number after the decimal point, so it's 1.8. So the answer to this question over here is the arc length is equal to 1.8 centimeters. So this thing over here is 1.8 centimeters. Okay? Now you're going to do a couple of problems like this on your own, and then you're going to apply them to something from the real world.